Hello and welcome to the first video of AI Programmer. And today we are going to start with the basic and one of the favorite algorithm for beginners is linear regression. So let's start with the agenda of this video. First of all, we will discuss what is the linear regression. Then we move to the how it is working. Then we will discuss what is the math process we're working behind it, then how we can implement it using the scikit-learn Python library without doing all the math stuff by just writing 4 or 5 lines of codes. And then we are going to do a small project for predicting housing prices of California. So yeah, that is the agenda of this video, and this is the small meme. My agenda is empty, and let's move to it. Okay, so what is the linear regression? Okay, so first let's start with a simple definition. It is a machine learning algorithm which is used for predicting regression tasks like predicting houses prices. Okay, so we can use linear regression for when we have various numbers like insurance price, housing price, and something like where we have deal with various numbers. At that point of time, linear regression will work. Okay, it is the basic algorithm that you may already know, and it is a good place to dive into machine learning. Yes, and the small meme, say linear regression one more time. Okay, so this is the small introduction of linear regression. Now we will dive into the process behind happening linear regression. Okay, so first of all, let's see this GIF image. Okay, in this image, this line is like moving with try to. We cannot say moving, but we try to fit this all the data points perfectly. And for that, it is changing the x and y, or we can say not x and y, but the slope of it. And by changing slope of it, it perfectly find the best fit for these various points. And this is the same thing what linear regression is also do. When we give the x parameter with a certain example, it try to fit this line on all the various example and define some m, or we can say slope parameter that can be used for future prediction with new examples. And with the new example, it will multiply with m, and then it will give us the output y. Okay, so let's understand it with some basic math which you already know. Okay, so this is the equation which you should know. This equation is a basic linear regression equation. This equation is, I think, you learned in your high school maths, where in the example they are giving the various x and various y, and we find the slope m. Okay, so this is the how we can relate this equation to our linear regression algorithm. Okay, suppose that I want to predict the price of y. So it is the y is my independent variable which I want to predict, and I have a number of bedrooms. Okay, so if the number of bedroom is 3, the housing price is this. If number of bedroom is 2, the housing price is this. Something like that. So bedroom is our dependent variable x. No, sorry. Y is our dependent variable and x is our independent variable because y is dependent on x. And this is the bias, or we can say constant parameter. That is doesn't matter for now, just y is equal to mx, and we need to figure out it what is the m for this given examples. Okay, now what if we have multiple input variable like this? So in this case we are predicting the prices, but we use various parameters for predicting price like bedrooms, bathrooms and balcony, and we will repeat the same process. Like first we use the y is equal to mx plus b, but here we use the multiple y is equal to mx plus b, and we can assume w1 has a m1, but w1 is appropriate character everyone is used in machine learning, so we need to use it. Okay, so this is the w1, w2 and w3. These three things we need to figure out it with to fit our line to various data points. Yeah, okay, so this for figuring out it, first we try with some random parameters, then we check what is the difference between actual parameter and what it predict. That this is the equation where I is the number of examples and n is total number of examples that we use for predicting. So if you don't understand right now, no problem, we will understand with full process. Like this is the multivariable linear regression example where we have xi. I mean the ith example, like we have 100 example, then we use the 1, 2, 3 and so on and so forth. For this is the for ith example, like for example 1 prediction, the number of bedroom is this, the number of bathroom is this, and the number of balcony is this. And then we count the loss function, like we first of all define the w1, then we define the w2 and w3 randomly first for first example, then we predict, we got some prediction, then we apply it to our loss equation where we find okay the y is $2,000, but we predict $1,500, so we need to figure it out to $2,000, and for that it will repeat the same process again for next example and change the w1, w2 and w3. Like in the y is equal to mx plus c, we will change the slope of the line, but this is the multiple line in a multiple dimension. So we again repeat the process and then we predict the for a new example and new W1, W2 and W3. Then we come to the count the loss. What is the actual loss? It is decrease or it is increasing. If it is decreasing, we will go on the same direction for further, and for number of example we will repeat this whole process again and again. Okay, so if you don't understand this math, and also just remember, I have multiple data points and I just need to fit a line to it with changing the position of it. Just remember that one thing. If you can't understand these maths, you will understand after doing some projects or some example of it, then you will understand better. Okay, so how to implement this whole thing? By just using writing 2 lines of code or 3 lines of codes. We have the scikit-learn library in the Python, where we first of all import the from scikit-learn.linear model and we import the linear regression. Then this is the basic term you must remember. For further machine learning models, we do the same thing, like we from the scikit-learn and we define it like reg. I define this whole algorithm as a reg. Then I give all the example that I have. X is equal to like independent variable, y is equal to dependent variable, and it will automate the whole process that we discussed earlier. This whole process will automated by just these 3 lines of codes. And now time for our live demo of linear regression. Okay, so this is the California housing price that we discussed earlier. I found this dataset from Kaggle. I will put the link down in this video so that you can try it with yourself. And this is the mean that more data mean more accuracy. That is the one rule in the field of machine learning is applied. More the data, more accurate your prediction is, because we can learn from more examples. Let's move to our project. How we will predict the house prices of this California data set. Okay, so I am using the Google Code Lab. You can use the Jupyter Notebook also, but I highly recommend you to use Google Code Lab, because for now learning is important instead of setting up the whole libraries and all stuff. Okay, so in the Google Code Lab all the library are pre-installed, so you don't need to wasting your time in installing various libraries. And maybe your PC is slow, then it will make more slow if you install this bunch of libraries. Okay, so for now I recommend you to use Google Code Lab, and I will also share this Google Code Lab link in the description below. Okay, so just let me open. Yeah, so I already import the dataset from the Kaggle with this four lines of code. This is the simple commands for importing the any Kaggle dataset in Google Code Lab without downloading it in your local machine. Then we unzip it because it is downloaded in the zip form. And I assume that you have a certain amount of knowledge of pandas and numpy. If you don't have, please go to some tutorials on YouTube of pandas. It is very easy. You can learn in 1 or 2 hours if you know already Python with some amount of like basic stuff in the Python. Okay, so first of all we will import the favorite pandas SPD, then we will import our scikit-learn library, that is sklearn dot linear model, and we will import. Okay, so now we need to load our data, which is the housing.csv. You can see here. Just let me copy the path. I use the basic pandas function pd dot read underscore exv here, and the path of it, and that's it. We load all the housing.csv file data into our data frame. So let's see how it is. Df.head, and here is the various parameter like longitude, latitude, housing, median age, total number of rooms, total number of bathroom, population, households, median income, median house value, ocean proximity, and wait. Okay, so we will use this median house value as a y, and this all the parameters for x. We can define it like we just need to like understand this whole parameter as a x and this one parameter as a y. Okay, so we saw our data, and now what we need to do is we need to define this one column as a y and this whole column as a x. We will do this with numpy array. We can do this with numpy array and also pandas, but we will use the pandas. Okay, so first of all we need to remove it for x. Okay, so what I will do, I use the df dot. Okay, so I will use df dot draw, and then I will define the column name, which is column is equal to median house. Just copy, paste it down here, and I use the axis is equal to 1, and that's it. Then we will do the same for in this case we use housing median value, and that's it. So when we run this, yes, so like let's see what is x dot, we can use head. Okay, so we remove the value of the median houses values, and we have the x parameters, and let's see for what is in the y. Oh wait, okay, so we have the y. I used just a head for now. Okay, so we use the y and x. Now we need to give this y and x to our linear regression model. So first of all, let's define the model. Reg is equal to linear regression, and that's it. And we will use reg dot it, and we will use x and y, and we will run this. Okay, so what's happened? Cannot convert. Okay, so this is the last line is the string, so I think I need to remove it for now, because machine learning algorithm can't understand the alphabets or a string, so it requires integer, float or boolean value. Boolean, not boolean, but 0 and 1. So let's remove that column also. Otherwise our model will not accept this. We can change this, but for now let's remove it. Yeah, so what's happened? Okay, so our data contains the null value, and that is the one thing we need to remove it, and that we can do with df. Okay, let's see, df dot drop and a function, and that's it. And we will save this as a df, and we remove all the null values, like which contains 0 or something like that. We remove all the null values, and then now I think it should work. And yeah, it is working. So now what I want to do is, suppose that I want to predict for new data, then what I will do, I use the reg dot fit, not fit, sorry, predict, and I pass this whole value as a list. This whole value, instead of this house value, median house value, I pass this all the different value, and it will give me a output. Okay, let's use this value for now. So we will predict this. We will predict for this first example. Okay, so x0 for the predicting for the first example, it will give me output. Okay, what's happened? Key error is 0. Okay, okay, so let's predict for first 5 example, and I got the different value, like, okay, let's just let me. Okay, so here what 411 for the first value, we have 455. Okay, and that's for second 20. Wait, okay, this is the point, 411.20. okay, pretty close. This is the 411.943. Close, but not that much, because we have the less data. So this is the 380534. Okay, this is pretty close. 322246, it is also close, and it is not that much close. For getting the accurate value, we need the more amount of data. Like this is, I think this is the very small, just shape. Okay, so this is 20,000 data, but we need to define some various hyperparameters, like what is the number of learning rate, and for now it is not good to dive into the whole parameter stuff. We will do the hyperparameter tuning in further videos, where we will Without getting more amount of data, we will increase the accuracy of this prediction. So yeah, that's it for this video, and I will be posting further videos related to various machine learning algorithms on this YouTube channel. And this is the first video, so please don't forget to like and subscribe this channel, because it motivates me for making the second video on this channel. Okay, thank you for watching, and also follow me on the Instagram, which is the same name here, AI Programmer, where I post the different stuff related to AI. Let me see. Okay, so I put the link of that profile also in the description to check it out. You will definitely get some amount of amazing content related to machine learning and AI. Yeah, thank you very much for watching this video. Bye bye and have a good day or good night, whatever.